Welcome. On this channel, we share the freshest insights from the world of neural networks, hardware, and technology. Subscribe right now so you don't miss a thing. And if you need your own AI agent, reach out and I'll help you build one tailored to your needs. Today, we are stepping into a truly magical explainer to uncover the mysteries of Google Diffusion Gemma. We are going to see how it brings a whole new era of local AI right into our very own homes. It is quite the journey.
Let us quickly outline our agenda for this inspiring journey. First, the diffusion text breakthrough. Second, the local hardware outpost. Third, speed and efficiency tests. Fourth, the compression quality cost. Fifth, multilingual and vision limits. And finally, the future of local AI. Let the magic begin.
Section 1, the diffusion text breakthrough. We begin our deep dive here, exploring how this clever new model leaves behind the ancient fragmentary writing of the past. You know how traditional LLM architectures work? They generate text strictly one single word at a time. It is a bit like carving chaotic, ancient fragments, just one by one. But Diffusion Gemma is totally different. It creates a simultaneous 256 token block. It brings this incredible order and harmony to the whole process. Think of it like painting a beautiful wide landscape all at once, instead of just dot by dot. This is absolutely crucial because it completely changes the speed and structure of how machines write for us. So how does this enchantment actually work? Well, the model first generates that massive box simultaneously. Then, miraculously, it cleans the noise in parallel. And finally, any uncertain words are quickly discarded and beautifully recreated. The entire text block is assembled in a single inspiring pass, bringing such great order to the digital text. By handling language in parallel like this, our local systems can process vast amounts of data, far more efficiently than those older sequential methods.
Section 2, the local hardware outpost. Now, let us reveal the rugged hardware required to deploy this mighty intelligence locally.
We actually deployed our mighty outpost on an Ubuntu system, housing a powerful NVIDIA RTX 6000 graphics card with 48 gigabytes of VRAM. It acts like a faithful guardian spirit, reliably watching over this rugged home server. We used a special local build of Llama CPP, specifically utilizing request 2423. The creators carefully compressed these heavy weights into a compact 4-bit format, known as a Q4KM model. This magical build weighs in at just 16.8 gigabytes. That makes it surprisingly accessible for home lab enthusiasts like us.
Now, the absolutely crucial metric here is 22. When running this model, it takes up just under 22 gigabytes of VRAM. We loaded all 99 delicate layers directly into the GPU, essentially awakening this system and allowing it to dream and think rapidly right on our own local hardware. Honestly, this efficiency is the true magic here. It proves that powerful AI no longer requires massive, distant data centers to operate.
Section 3, Speed and Efficiency Tests. We transition to the gauntlet now, starting with rigorous stress tests to measure the speed and hidden thought process of the algorithm. We first asked for a very simple smile on camera, and the result was absolutely perfect. Like a swift mythical hound, it actually stopped ahead of schedule, completing the task in 41 steps instead of the usual 48, saving precious resources. Then, we asked a complex physics question about tropical storm eddies. Like a mighty god of the winds, the model deeply understood the topic and gave a university-level answer. However, the generation rate did drop to 26 tokens per second for this heavier task. It really shows the careful balance between speed and deep reasoning.
Section 4. The compression quality cost. Next, we discover the harsh price paid for compressing these delicate digital weights into a smaller file size.
During an engineering test, we asked the model to write an HTML file simulating moving tectonic plates. The full, uncompressed model produced a beautiful depiction filled with small, important details. However, the compressed models suffered a colossal loss in visual quality. It was almost as if a cunning swamp spirit intervened, erasing all of the fine, delicate details during the harsh compression process. This trade-off is so essential to understand, because fitting a massive mind into a small computer inevitably sacrifices some of its artistic precision. Section 5, Multilingual and Vision Limits. Let us continue the gauntlet to examine the boundaries of this architecture when faced with ancient scripts and rare dialects. Right, so there are some frustrating obstacles. First, optical character recognition completely failed when we loaded an old, handwritten letter. The console version is sadly limited to plain text right now.
Then, a mischievous forest spirit seemed to entangle the long, glowing threads of our multilingual wedding dress test. The model was completely unable to distinguish between dialects. An Indian language received a random alien Chinese character, and Cambodian text was awkwardly mixed with Thai script. These limitations show us that while the core engine is powerful, its worldly senses are still developing.
To put it bluntly, the results were completely unreadable. Verbal garbage during a Greek translation test. The harsh compression clearly causes annoying, chaotic errors when dealing with complex language tasks. It is a stark reminder that even the most magical algorithms have fragile limits, especially when translating the beautiful diversity of human language through heavily compressed pathways. Section 6. The Future of Local AI. Finally, we look at what these inspiring discoveries mean for our emerging digital world. There is a profound truth emerging here. Artificial intelligence is becoming sovereign, fast, and incredibly accessible right on home hardware. Despite those annoying language errors, we have definitely proven that diffuse text generation holds enormous potential. You will soon be able to run incredibly intelligent, creative algorithms right on your own home servers. This shifts the power away from massive corporations, returning the magic of creation directly into the hands of the individual. We end this explainer with a final provocative question. Is sovereign, local AI the true future of our digital world? As this inspiring era arrives, running locally on our very own hardware, we really have to wonder if this decentralized magic is our ultimate destiny. Thank you for joining me on this incredible learning journey.